Now, welcome. Today I have prepared for you a very crucial area and specifically I want us to look at something concerning integral calculus, so the so-called calculus 2, as you know. Now, specifically I want to deal with one of the method, that is substitution, how it is being applied in integral calculus. Now, I want to use three different equations that will enable you to summarize the method, that is substitution, as one of the method used in integral calculus. Now, the first question I have here is that is question A. Yeah, the question states that find the integration of in x over x dx. Now, how can we perform this? Now, I'll come here and write now that is the solution so that we can see how we can solve this problem here. Now, when you look at here, the content here, I have in x, the value, this letter here, normally it confused. The best way of pronouncing it should be ln. So you are required to pronounce it as ln x. Yes, I hope we are together. So you are supposed to integrate ln x over x dx. Now, how can I perform this? Step number one, you are required to separate ln x with x. In short, you are just supposed to use that integral sign. Then you just say, because ln x over x just the same as 1 over x ln x. That is it. So I'll just write 1 over x ln x dx. Yes. So after writing that, in short, after separating them the way I've done so, you are now supposed to say that this ln x, it is better to let it to be a letter like u, so that the moment you see ln x, you will be in a position of seeing that is u. So you are just supposed to say that let ln x be u, and therefore having lettered ln x be u, then I'll be in a position of coming up with the new values, that is 1 over x u dx. That is it, because I have said let ln x be u, and what is it? Ln x is now u. So where ln x is, I just substitute with u to come up with this. Now, after this, the method was substitution. You are required to differentiate in a manner that you will use the values that correspond to dx. You are supposed to substitute dx with the differentiation of that is du dx, because when you differentiate du dx, you will come up with a value that when you let dx now to be the subject of that formula, then you will come up with something du. So that one is what we shall be substituting here. And therefore, I'll now come and say that how can I get du, so that I can substitute it with the x. So du, to come up here, I've said that let ln x be u. And therefore, when I differentiate this ln x, I'll come up with du, which is equals to 1 over x, because when you differentiate ln x, you will come up with 1 over x. Then you add here dx. Now from here, remember, it is substitution. Therefore, I need to be making this dx to be at its own side, so that I be able to substitute the value that is du here on the place of dx. And therefore, how can I ensure that dx remain this side alone? By coming here, by multiplying by the reciprocal here. So the reciprocal of 1 over x is probably x over 1. So I'll just come here and just multiply by x over 1. I've failed to put a multiplication sign here, because when I put multiplication sign here, it will be similar with my x. So I've just assumed that that multiplication sign I've already sorted it. So when I do such, or probably this x, when I multiply, let me just use a dot, because dotted line, a dotted sign just means multiplication. When I multiply by x here, that one means that this my x here will goes with this, so that I remain with the dx this side to be equals to x du. Now after writing that, when you come up here, we say that I'm seeing dx here, and as per now you are in a position of finding that my dx is equals to x du, and therefore up here where dx is, you are supposed to substitute it with that is x du, and therefore you will just come here and say it is integral sign 1 over x, remember it is 1 over x, u. Then what is dx? Dx, I've realized that it is x du. So that's what I write here. So dot x du. Now after reaching there, you can see the uniqueness here that this x probably will goes with that x. And when it does so, you will finalize by saying that my remainder is just integral of u du, because that's what remained here. Now as you can see here, it is very easy to integrate u du by saying the power here is 1. So when I take 1, then I add 1, I'll get 2. Then you are supposed to divide by the power, the general power here, which is 2. So you'll come up here and now finalize by saying that it is now u raised to 2, because 1 plus 1 is 2. Then you just divide by this power here. So I divide by 2 plus a constant. Remember, by integrating, you need to be adding that constant there. Now after this, you can as well separate this by saying is the same as now a half u squared plus c. I think you can see there. Now up here, remember that we say that let that is ln x be u, and therefore where we reach, you are required to substitute a u with ln x. That is it. So where u is here, I just write ln x, and therefore when you do so, I'll be finalizing by having a half into, because ln x, I'll need to be writing it here, so ln x. But what was it? Remember the content here, ln x was u, but u is squared here, so I'll come here and square that one. Then you are required to now to add a constant c. Now friends, after reaching there, you will have gotten the integral of what the question wanted you to find. Now since I've told you that I want to use 3 different equations that will enable me to summarize, that is a substitution method, let us look at the second part of that question. And the second part that I've prepared for you here is that find the integration of sine x cos raised to 5 x dx. Now in case you've been provided with this, remember here you are now having sine and cosine. Now in case you are having sine and cosine here, you are supposed to say that the first step under solution here should be, that is solution, let me write it first. So under solution here, remember you can't work out that is cos 5x at once. So it is better to let cos x to be u, so that where cos x is here, I'll just be substituting it to be u. And therefore, by saying that, I'll just come here and say let cos x be u. Now after writing that, you are now required to substitute where cos x is, just write u. For instance, it is cos 5x and cos x is u, and therefore when I substitute cos x with u, it will be now u raised to 5. That is it. So that's what I write here. So I'll come now here and say it is integration sign of sine, that is x, it is now u. Remember it is cos x is u, raised to 5, so that is raised to 5. Then I have my dx there. Now friends, after reaching there, your work is now very easy, because I've told you that the method is substitution. You are required to differentiate in that you have dx on one side, and therefore how can I do such? I'll now come here and say write du. I differentiate this, that is cos x, because when I have cos x is equals to u, therefore when I differentiate cos x, probably I'll be having that is negative sine x dx, and that one will enable me to remain with the dx on one side, so that I can be able to substitute it here. And therefore that one will be now the way I've said that when you differentiate cos x, probably is negative sine x dx. But remember, I've told you that I want to ensure that this dx is on its own side. How can I make it to be its own side? By so dividing by negative sine x, by so dividing by negative sine x. Now friends, after doing such, you realize that this negative sine x goes with that negative sine x, such that you will remain with dx being equals to du over negative sine x. I think you are following. Now after that, remember that we say now here that we are supposed to substitute dx with that is du over negative sine x. So where dx is here, you just require to write that is du over negative sine x. So that is it, and the rest just leave them the way they are. So I'll come here now and say the integral sign of sine x u raised to 5, remember that is what is here, then it is dx, and what is dx? Du over negative sine x. So I'll come here and say that is now du over negative sine x. Now when you look at what I've written here, you can see the uniqueness in that this sine x can goes with this sine x, so that I only remain with the negative there. So when you take a 5, that is u raised to 5 over negative, you will end up by having that is negative u5 du. Now probably up to where we are, you can you can integrate negative u raised to 5 du. Now how can I work out that? To integrate that, you are required to add 1 to this power, then you just divide by the general power. So when you add 5 plus 1 is 6, so you're required to take that 6, divide it here. When you do such, you will remain with that is negative 1 over 6, but it is now it is 6, because 5 plus 1 is that is 6, then plus a constant. Remember, I've told you previously that when you're integrating, you ensure that you add a constant c. Now after that, remember up here we say that let cos x be u, and here I'm seeing u here, and therefore what are you supposed to be doing here? You are supposed to substitute this u with what was it? It was cos x. So instead of me having u there, I'll be seeing that is cos x. So I'll come here and say now that it is negative 1 over 6 cos, remember it is cos x, but u is raised to 6, therefore it is cos raised to 6 x, then a plus a constant c. So after reaching here, you will have reached the final integration by substitution as you've been asked, and that's how you are supposed to perform that. So what you need to be doing or what you need to be knowing here is how can I integrate that is sine x and how can I differentiate as well sine x, and as well how can I differentiate cos x, because those are some of the things that you need to be highlighting here. Now after working out that, because that is a B part of the question, I want us to look at the C part of that question so that we can see how else the question under substitution can be asked. Now look at that now. In this time round, you can see that we have now exponential. Now as per now, I want to show you how we can perform integration with the exponential, because working out exponential sometimes become a problem. Now how can I work out this? So instead you've been given exponential, you're supposed now to come up here and write that is solution here. Let me write that solution here. Now you can see that is exponential cos x. Working out exponential cos x at once sometimes is very tedious, and therefore under here you are required to let this cos x to be something like u, so that I'll be substituting cos x with u, and therefore that one marks my first step. So I'll come here now saying that let that is cos x be u, and having letted cos x be u, that one means my new values here by substituting cos x with u shall be that the integration of sine x exponential of u, remember cos x is u, and that's why I've written u there, then I have dx there. Now the method was substitution, and as you can see, what we are substituting is just dx, so that we can integrate the remainder. So you are supposed to find a way of which you can substitute this dx, and that one can only be through differentiating du dx. That is it. So I need to be differentiating du dx so that I get dx on one side, and the value opposite to the other side of the equal sign I'll be substituting here. Now what can I work out that? I'll come up here and say that is du therefore is now equals to, now let us come here, cos x. How can I differentiate cos x? Cos x is just negative sine x. So I'll come here and say negative sine x, but I was differentiating du dx. So I'll come here and write that is dx here. Now after that, remember I've told you that I require dx on its own side, and therefore I need to be dividing by negative sine x. I divide by negative sine x, such that when I work out that, remember this one goes, you will be remaining with, that is dx in this on this side here,